Hello everyone, I'm Paul and today we're solving problem 3201. Find the maximum length of valid subsequence 1. This is medium but might be tricky, so here I will show you how to solve this step by step. We are given an integer array nums and we need to return the length of the longest valid subsequence in nums, and this is the requirement for a valid subsequence. If we take two adjacent elements modded by 2, the resulting value should be the same for any two adjacent elements in the subsequence. That's what this means. Let's say we get this array. In case you know what a subsequence is, if we remove these and these elements, the remaining elements form a subsequence. If we remove these and these, for example, these remaining elements also form a subsequence. And if we don't remove anything, we also have a subsequence. So we can get a subsequence by removing some or none of the elements in the array without changing the order of remaining elements. Now, going back to a problem, this is the requirement for a valid subsequence. And I think the key here is observation. So let's try a few patterns. Let's say we get this subsequence. Here, if we take the sum of these two elements modded by 2, this is 2 modded by 2, 0. So the result here is 0. If we do the same here, the result is 0. And if we do the same here, the result is 0. And given that we have all zeros, we meet this requirement, so this subsequence is valid. Now let's say we take this subsequence. Here we do the same. We take these two values. 2 plus 2 is 4, modded by 2 is 0. So the resulting value here is 0. We do the same here, and the resulting value is also 0. And given that we have equals values here, we meet this requirement, so this is also a valid subsequence. Now let's say we take this subsequence and we do the same here. The sum of these two values is 3, and 3 modded by 2 is 1. So the resulting value here is 1. We do the same here. The sum of these elements is 3, and 3 modded by 2 is 1. So here we have a 1, and here we have another 1, here we have another 1, and here we have another 1. And given that we have all ones, we meet this requirement, so this is also a valid subsequence. Finally, we can take this subsequence and we do the same. 2 plus 1 is 3, modded by 2 is 1, so the result here is 1. Here 1 plus 2 is 3, modded by 2 is 1, so we have another 1 here, and we have another 1 here. And given that we have all ones, this is also a valid subsequence. Now let's say we take this subsequence. So we remove this, and we take this subsequence. Here the sum of these elements is 3 modded by 2 is 1, so the result here is 1. The sum of these elements is 3 modded by 2 is 1, and the sum of these elements is 2 modded by 2 is 0. And given that these results are not all equal, this is not a valid subsequence. So you can try this as much as you want, but here are only 4 valid patterns, and these are the patterns. These are the only 4 valid patterns. We have a valid subsequence if we have all odd numbers, or if we have all even numbers, or if we have add, even, add, even, add, even. We'll call this OE for add, even. Or if we have the opposite, meaning even, add, we'll call this EO. So the approach is simple. We'll iterate this from left to right, and we will keep track of the length of each of these subsequences. So we will do the following here. We will have variables to keep track of the length of each of these subsequences, and these will all be 0 initially. And we will have 2 more variables here. One will be the required value for even add, because remember, first we are looking for an even here, and once we find an even, we need to change this to 1, meaning now we're looking for an add. And this variable is the same for add even. We initially are looking for an odd number, and then we are looking for an even number, so we transform this into 0. And then we are looking for an odd number again, so we transform this into 1, and so on. So now we can iterate this, and first we start here, and 1 is add, so we can add 1 to this count for odd numbers. And right now for add even, we are looking for an odd number, and this is add, so we add 1 here also. And now we're looking for an even, so we change this to a 0. Now we are here, and this is even, so first we add 1 to the count of evens, and then we are looking here. We have an even, and we are looking for an even here and here. So we can add 1 to add even, this is now 2, and we add 1 to even add, this is now 1. And given that we found an even, we can change this 2 to 1. Now we are here, and 1 is add, so first we add 1 to add, this is now 2, and now we are looking here. We are looking for an add in both cases, so we add 1 here, this is 3, and 1 here, this is 2. And we need to change this to 0 again. Now we are here, this is add, so we add 1 to add, this is 3 now. And now we are looking here, and we are looking for an even, and this is add, so we continue. Next 2 is even, so we add 1 to this count, this is now 2. And here we are looking for evens, so we add 1 here, this is 4. We add 1 here, this is 3. And now this is 1, and this is 1. Now we're here, this is add, so we add 1 to add, this is 4. And now we are looking here, we are looking for an odd number, and we have it. So we add 1 here, this is 5. We add 1 here, this is 4. And we need to change this back to 0 again. Now we're here, this is even, so we add 1 here, this is 3. Now we are looking here, and we are looking for an even, so we add 1 here, this is 6. We add 1 here, this is 5. We change this back to 1. Now we update the I pointer, we reach the end, and we need to return the maximum value among all of this. And here it's 6, so we return 6. And remember, this subsequence corresponds to 1, 2, 1, 2, 1, 2. So this is it for the approach. Time complexity will be big O of n, because we need to iterate this, and space complexity will be big O of 1. So now let's go with the code, and hopefully you will get the idea. First, we need to create variables to keep track of counts for every pattern. So we will call this even, add, even, add, add, even. And these are 0, 0, 0, 0. Now the initial required value for even add and the initial required value for add even, these are 0 for even add and 1 for add even. Now for every value in nums, first we check the parity of the current value, so x modulo equal 2, and now we can say if x equals 0, we add 1 to even, else we add 1 to add. Now if x equals to the required value for even add, we add 1 to even add, and we need to change required even add. So we do required even add XOR equal 1. So if this was 0, now this is 1, and if this was 1, now this is 0. And we need to do the same for add even. So if x equals required add even, add even plus equal 1, and required add even x or equal 1. And finally, we can return the maximum among even, add, even, add. So this is it for the code. Now let's submit this and see if it works. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.